a technical program manager at Google DeepMind, right? More specifically, you are at WeatherNext, right? So maybe tell me a bit about this program and what it is and what you're trying to achieve and maybe some of your results so far.
Yeah, sure. Well, first of all, thank you so much, Raph and the Sweep team for having me. It's really a treat to be here and also to hear about all the awesome work in sustainability that people in this room are doing. Like, it's so cool to hear about, oh, I invested in a new oven, but I don't get to do that in my job. So it's really great to feed off of the inspiration across the board. And maybe I'll start by explaining kind of what DeepMind is and kind of what we do. So Google DeepMind is the AI research arm of Google, we really focus a lot on trying to push state-of-the-art on achieving AGI and advancing AI with science. It's one of the frontier labs, along with peer companies like OpenAI and Anthropic, working on a similar goal of achieving AGI. And we have a sustainability research program at DeepMind that I help manage, and I sit on our sustainability leadership team. And we have a series of research projects that are related to building awesome machine learning models that will advance sustainability with AI. And one of our largest research projects is our WeatherNext project, where we're working on weather models. So going back to your question about what those are, and you had asked a question about that, right?
Yeah, so what are results so far maybe from that research project? And then I'll ask you in a moment about Weather Lab as well, of course, but more generally, what's the sort of breadth of projects that you work on there?
Yeah, so the results we're seeing so the weather research world has been really exciting in the last, I don't know if folks in this room have been following. Even before I joined the team, our first paper called GraphCast, which is now our model WeatherNext Graph, was pretty transformational in that we showed that you could outperform traditional numerical weather prediction models, which are like large physics-based simulation models. They run on these massive supercomputers. They take a really long time to churn out a new weather forecast. So imagine like trying to, churning for hours on tens of thousands of processors. We replaced that entire model with a model that's learned on historical weather data. And it sounds simple when I describe it, but it was actually very hard to do. It was a very hard engineering task. And we showed that actually you can replace the entire physics-based simulation model with a machine learning model that's learned, given the previous 6-hour global weather state, the current global weather state, give me the next 6 hours, give me the next 12 hours. And, we can run a 15-day, weather forecast for a given initialization time on, for example, 1 TPU in 8 minutes. So.
Okay, great. And so you've applied all this to a project that's called Weather Lab, right? And you just launched this last week, was it? Right. So I think we're very lucky to have you. Tell us a bit more about that.
Yeah. Thanks for asking. So just last week we published this website. It's pretty cool. You can actually check it out if you Google like Weather Lab DeepMind. It's this website where you can visualize our latest experimental cyclone model and how it compares in performance to other cyclone models. And you can actually see, sort of how good these various models are doing at the task of cyclone tracking. So understanding cyclone tracks, cyclone intensity, cyclone type. Is it a tropical storm? Is it a tropical cyclone? And I think the significance of this work is that, we're really trying to push, we have sort of a work stream within WeatherNext where we're trying to push state-of-the-art on making our models better and better at trying to predict hurricanes. And this is work that we're doing in partnership with the National Hurricane Center in the US. And so this summer, they're going to be downloading our data, and we're going to be doing this sort of evaluation work with them to understand, okay, how can we actually start making some of these machine learning models available for operational forecast use? And the significance of this work is pretty big. We haven't actually published hard metrics on here are the average number of days in advance you're getting an accurate forecast for. But we see these examples where we're like, oh my gosh, like that hurricane, we were predicting that hitting, that part of Florida like 2 days before any other model. So we're, of course, it's not always the case. You cherry pick examples, and so we want to be able to show good evaluations, and so that's why we're sort of putting this out there, working around this partnership, and trying to help the entire scientific community kind of push on the evaluations.
Great. Do you see any ways this can help us combat the effects of climate change, or maybe mitigate them?
Yeah, definitely. I mean, I think weather in weather research world broadly, and well, definitely on disaster preparedness when it comes to cyclone tracking, when it comes to being able to better, anticipate extreme droughts, extreme wind events, et cetera. And if you take, a weather model that is more efficient, more accurate, and you apply it to your downstream task, for instance, like power forecasting is a really exciting area, and that's one that can have a pretty significant carbon impact. Is if we can, have better weather models. There are actually these papers. I wish I had like the number. I'm not that good at like remembering the stats I read a year ago. Some people are like, oh, remember that percentage. But there are these papers that show like, if we increase the accuracy of our weather models by X%, you get Y% uptake in wind and solar compared to oil and gas, because you can sort of, predict wind and solar generation better. And so folks that are like doing grid operations work, they're not going to need to hedge more on kind of procuring more oil and gas or generating more oil and gas or whatever, in comparison to if that sort of cone of uncertainty around your like wind and solar generation prediction is more narrow, right? So I think
cool.
Those are two pretty big areas.
That's great. So super fascinating. Let's talk about the elephant in the room, though. We know how power hungry and sort of how much water AI consumes as well. So we see the benefits, but also how do we sort of mitigate the downsides? What's your take on this?
Yeah, I mean, it's definitely no secret that like our these large language models consume a lot of energy, in particular on the training side. And what we're seeing right now is efficiency gains are pretty dramatic, especially on the costs involved in serving these large models is going way down, and people are seeing lots of advancements in terms of using smaller and smaller model sizes, which is also great for that. Nonetheless, we still have this like big problem, and one thing I like to sort of focus on, including in our work, is like, well, what's the carbon upside of this investment? If we're investing all of this sort of emissions into building these large language models, what are we going to get in return? And there's so much exciting work happening on understanding how we can accelerate research and science with generative AI. We're experimenting with these models all the time within DeepMind, and we're finding that, for example, there are models that people are publishing on showing, models that can actually like do research, that can sort of write papers. You sort of cast that net out to thinking about, okay, well, how is that going to accelerate the scientific work across energy, weather, right, medicine, genomics, all these areas. So there is a big upside to investing in accelerating science, and we've seen that in various technological transformations, but we are encountering this sort of upfront cost. And there's a bunch of work to make it more efficient, procure more renewable energy. There's a silver lining around, yeah.
Okay, and so I guess, it's like a budgeting exercise, right? You see where you think the benefits outweigh the cost, and ultimately you need to stick to your carbon budget, for example, right? Great, maybe one last quick question, and then we'll wrap it up. We have a lot of business leaders here choosing AI tools at the moment. Any advice you'd want to give them?
Yeah, so I guess I think about two things. One is, definitely, if you're thinking about how to incorporate like AI into your org right now, like that, now's a great time to do that. And I'd encourage folks to maybe, try to think 2 steps ahead, right? And, beyond the chatbot paradigm, beyond like incorporating AI as a tool that can sort of be used as sort of a knowledge assistant like type thing. the path to AGI is a very interesting one that sort of can transform a lot of businesses. And so, spend some time really thinking about, what it might mean if, for example, a model like AlphaEvolve can, produce new math and new complex algorithms that scientists have been working on for a long time. What does that mean to sort of the area or discipline that you're in? So, kind of being prepared for that, I think, is sort of what I would do, I guess, if I were in the shoes of a business owner or manager. The second thing is, I feel like when I talk to companies, particularly in the energy space, when you're adopting like an AI tool, we spend a lot of time thinking about how do we evaluate stuff? Like, what are the metrics we're trying to hill climb on? Metrics are so important to us. We're so metric driven. We evaluate everything extremely rigorously. And sometimes when I talk to companies, I think companies need to move faster. They need to be more nimble. And maybe you'll take data from 3 different vendors, you'll mix it, and you'll be like, oh, that sort of helped my revenue goals. And then, oh, I included this other data from another vendor, and it seemed to uplift my revenue goals, and that's pretty good. But usually, sometimes I'll talk to companies, and it sounds like there's not, oh, we don't really have clear baselines, we don't really have a clear metric methodology, or I'll ask like, how did you get that? And that makes it hard to understand, I think, like how is that new data set or that new AI capability actually helping your business? So just really focusing on the metrics and the evals, and that's something that Sweep can help with, right, on the carbon reporting side too, and keeping you honest to your data.
Great. Yeah, maybe track those KPIs in Sweep. Thanks so much, Ben.
Yeah, thanks, Raph.